Okay, so the grand central station of your audio world has to be in the mixing console. All of your inputs come in, and then all of your outputs go out. You get to blend all of your sound sources and send them off to the front of house speakers and then back to the performers on stage, through monitors or in-ear monitors, and then also even out to recording devices or computers. Now, when I started, all the mixers were analog, meaning that they were a sea of faders and knobs and resistors and capacitors and transistors all under the hood. Most mixers nowadays are digital, which means, actually affords a number of really great benefits. For one, the costs have dropped down dramatically. They also have a ton of effects built in because it's cheap to add effects software into a digital board. An analog board actually needs discrete components to add effects. Now, while it's pretty standard to have compressors and gates on every channel on a digital board, that would totally be cost prohibitive on an older analog board. So, in light of this, I'm actually going to start you off on an analog console. Now, why the heck would I do that? Well, a couple of reasons. Some of you will be mixing on analog consoles. Maybe there's some rooms in the facility you're in that have analog consoles, but the bigger reasons to use an analog console is it's easy to grasp signal flow and how everything works because there's a dedicated knob or button for basically everything. Now, once we understand how a standard old school mixer works, it's really easy to translate that knowledge into running any newer digital mixer. By the way, there are a lot of mixers out there, and they all have slightly different ways of doing the same task. It's really my job in this section to make you so familiar with how an average mixer works so that you'll just be able to walk up to any mixer, and just not break a sweat. So let's see an illustration of what goes on inside a fictional mixer. Okay, let's take our made-up mixer. It's just an on-screen graphic that can kind of give us an idea of what mixers do when we actually look at real mixers in a moment. So in this fictional mixer, I have an SM58 plugged right into the first input, and the signal from that goes through the EQ and the Aux Sends and then goes out the left and right bus, which then goes out of the mixer and then feeds those speakers right there. Now, a lot of mixers will have, in addition to all those input channels, they will have subgroups. And here's what you can do with subgroups. So, in fact, let's look at a mixer like this. You might have seen a naming of mixers, something like this, a 12/4/2. What that means, there's 12, in this mixer here, we have 12 input channels, 4 subgroups, and 2 outputs on this. It's one stereo channel, but technically when you're thinking about it, a stereo path is really 2 paths. So that's why they call it a 12 into 4 into 2. 12 inputs through 4 subgroups into a stereo left and right out. So let's imagine we have a whole drum kit coming through here. You've got a kick drum, snare drum, hi-hat, toms, and overheads. That's about that's 7 inputs. And all of those could just go to the left and right, but how about we use some subgroups? Instead of just sending them to the left and the right, we could send them out to subgroups. So let's take this example here on this mixer. Sometime on a digital mixer, this will be probably done within some sort of screen, but in analog mixers, there were typically these little button assignments down here, so that instead of going this to left and right, we could send it out to a subgroup. So you had that choice between sending it out to a subgroup or directly to a left and right. Let's imagine that we wanted to take this and assign it to subgroup 1. So now the signal from that kick drum, instead of that going down through here and going over the left and right, it would not go there because we've set up to being going out to subgroup 1, it's going to go over here. So you might be thinking, well, why am I sending it over there versus just the left and right? Well, imagine this. Imagine if we set all of these to subgroup 1. That way, the output of all those input channels would come across here, and we would have control over your entire drum kit just on one fader. So in other words, if you wanted to bring the drums up and down, you do it right here. If you wanted to just change, I don't know, just to say the level of the snare drum, you do it individually across here. So another thing to think of in terms of mixes are our Aux Sends. And Aux Sends are basically a way to siphon off differing amounts of each channel, and they go somewhere. Well, where is somewhere? Well, you can use them to feed your onstage monitors, you could use them to feed your in-ear monitors, or you could use them to send to your effects sends. So let's imagine a setup like this where we have 6 Aux Sends. We could use the first 2 for effect sends. So say, for example, the top effect was reverb and the bottom one was delay. You could send differing amounts of each channel to have differing amounts of reverb and delay. And then you'd have also using, say, 3 and 4 to go out to on-stage monitors, and then maybe 5 and 6 to feed out to in-ear monitors. So basically 3 through 6 could be monitor mixes. A total of 6 Aux Sends, 2 used for effects sends and 4 used for monitor mixes. And that brings up the subject of pre or post Aux Sends. On most mixes you might have seen this option where you can set things up as being either pre or post. So let's fade the Aux Send out for the moment and just look at the fader. A fader's job is pretty simple, right? If it's set up to unity, then whatever comes in the input of that fader will, if it's set up to be unity, will basically come out. It'll be a 1-to-1. If you bump that up, then it'll amplify that signal. If you bring it down, it will attenuate that signal. That's, mixing 101 there. Okay, but now let's talk at Aux Sends and how this all works. Aux Sends can either be set up to be pre-fader or they can be set up to be post-fader. So what are the applications for both of these? Let's start out and look at the pre-fader and an Aux Send. If we were to send that out to an effects send and it was set up to be pre, here's what would happen when we move that fader. We bring it up. You'll notice that the Aux Send has not changed because it's before that fader. If we bring it down, you can hear how the original signal has gone away, but the effect is still there because that send that goes out to that effects unit was not affected by that fader because it was before it. Remember, that was a pre-send. So let's compare that if we were to send that over to post. Now when we bring it up, notice the effect level goes up in the same relative way. If we bring it all the way down, not only has that killed the original signal, it's also killed the send to that reverb because it's post fader, right? All of that routing is happening after the fader. So let's have a look. And by the way, that's the exact reason why you would not want to set up a monitor send on a post fader, because then if you start messing around with that fader, you will start messing around with the monitor mix on stage. So a better way to do all of this is to typically set up your monitor mix to be pre and your effects sends to be post. Again, the monitor mix, when it's set up to be pre, the great thing about that, you set that knob, that monitor mix up, and it will not be affected by your fader. You do really want that to happen with your effects sends because you don't want to have phantom effects sitting around. Unless you want it for a specific situation, you'll typically want effects sends to be post. So here's a pretty typical analog mixer. This is a 12x4x2, basically 12 input channels here, going into 4 subgroups into the main left and right bus. You might see this notated as a 12.4.2. And here's the big secret with any kind of mixer, is that it doesn't matter how many input channels you have here. Once you know exactly what one channel strip does, it doesn't matter whether you have 12 or you have a schmillion, you will know your mixer here. So let's just look at this first channel strip down here. First thing we do is plug in our sound source in either a 1/4 inch or an XLR. And then the first part of the circuitry normally your signal will see within a mixer is the trim pot or the gain knob up here. And the purpose of a trim or gain is to pre-amplify that signal, because your mixer doesn't really know what kind of signal is coming in here. It could be a fairly strong signal from, say, a drum machine or a keyboard, or it could be a very weak signal from a microphone that you really need to bump up a whole lot. So basically the idea behind trims is just to really get everybody on level footing. Maybe this one needs to be boosted a lot, this one only needs to be boosted a little bit, this is somewhere in the middle. So we'll look into gain structure in a moment, but basically that's the idea behind a trim pot here, is just to boost up that signal so they can all be kind of on a level footing. Now, once we get below that, we have our Aux Sends, which allow us to send a part of this signal that's going down this path someplace else. And in this example, there's actually some Aux Sends up here. So whatever will be connected up here, you could send out a portion of this out to this, and that could go elsewhere to a monitor send or external effects or something like that. We then move down to our EQ, and in this case, this is a 3-band EQ, a fixed low, a fixed high, and then a sweepable mid-range here. Then we have our pan pot, and then our fader, and then various assignments down here where you can either mute that or send it over to subgroups and so on, and solo as well. But before we get into any of the bells and whistles, the first thing we need to look at is the gain structure of this or any mixer. You've really got to get familiar with the gain structure. And typically it goes along like this. Your input comes in, the path goes to your trim pot, then to your fader, and then elsewhere to your subgroups and main left and right bus. But this is where your signal noise and your distortion will, you'll either get a great signal or you'll get a really poor signal. And basically, most of the time on these mixers, they'll have a little overload LED up here, and you just basically want to hit this as hard as you can before that lights up. So let's just bring that up. It's got a kick drum coming up here. So that's lighting up. So let me just back that off a little bit. That looks about right there. Let me just stop that. Now, the sensitivity of this light will change from mixer to mixer. I've known mixers that as soon as you hit the red up here, then you distort and it sounds horrible, and that way you need to back it down so it never lights up. I know there's other mixers that have a fair bit of grace above when this light goes up. So the whole idea is throw some headphones on, really listen carefully and see how the distortion you hear it corresponds with this light. Does it start distorting as soon as the light comes on, or maybe does it give you a little bit of grace and you can light that up just every now and again? So basically I've done the same thing with my snare, hi-hat and bass guitar. So here's what it sounds like. Now what I've noticed with this hi-hat, I could have hit the trim up a little bit higher here, but very fast transients sometimes don't light this up. So sometimes you can actually use your ears as well to be able to hear where that's distorting. The level of the hi-hat, because it's a sound that really cuts through the mix, I would probably bring it down a little bit here. So this is probably, yeah, this is sounding about right. And that last snare hit was a harder hit than the rest. That lit that up. I didn't hear any distortion, so that should be about right there. So you can see everything starts with the gain knobs and then goes through here. You typically want to have your faders around the 0 dB, which is the shaded area on most mixers. Sometimes it has a little U or a unity there. And you typically want to live about that around there. As I've just mentioned a while ago, the hi-hat, because it cuts through the mix so much, I might back that down a little bit. Don't make the mistake where you want everything to be at unity and then adjust your gain there. Adjust your gain first, and then this So this is all about setting levels. This is about how you like everything to blend in within a mix. Okay, so moving on down from there, we have our Aux Sends, which allow us to send varying amounts of whatever's coming down this channel, which is kick drum in this example, out to various places. And it might be a monitor send, or it might be an effects. In this case, we have internal effects and external effects within this mixer. And then we move down to our EQ. And in this case, we have 4-band EQ. We have a fixed low set at 80 hertz, a fixed high at 12 kilohertz, and then a sweepable mid-range here. So this would be called a low shelf and a high shelf and a semi-parametric EQ here. And typically on all of these, they have like a center detent, like it kind of clicks together at the 12 o'clock position. That means in this case of this 80 hertz, you're neither boosting or attenuating that 80 hertz point there. But if you wanted to boost up some of the fundamentals of that kick drum, you could move it to the right. I think in this case it goes all the way up to 15 dB, or you could pull down up to 15 dB of this 80 hertz right there. And the same thing on the top shelving, we can boost up 12 kilohertz all the way to the right, or we can pull down 12 kilohertz. Actually, let's listen to this. Let me just listen to this. And the top end, you can hear more of that beta. That's more dull. And then the middle one here allows you to do the same thing, boost mid-range or cut mid-range, but it also allows you to sweep that around. So let me boost that up, and then we sweep through our lower mids to our high mids. So in this case, with all of these set all the way up the middle, the blue knobs are the actual gain of the frequency. So in other words, the gain of the low EQ, the gain of the high EQ, and the gain of the mid. As long as they're set up to about the 12 o'clock, that little detent position, then we're neither boosting or cutting out. We're actually not using this EQ in this situation. And then finally, we have our pan and our subgroup assignments, which we'll look at in a second. Okay, so moving on to effects. In this case, we have an external effects loop, and then we have the internal effects loop, which use the effects right over here. So let's have a listen to our kick and snare. Now we can add varying amounts, basically send varying amounts of this kick drum over to the effects using this effects send. So hear that? There's a lot of reverb on that kick. Now a lot on the snare. Or you can have a varying amount of each. So basically what's going on is this is an effects send that goes out to this effects. So basically vertically you have all of your inputs, and then horizontally we have varying amounts of that going out to our effects send. Like our effects send 2, which sent to our internal effects right here, effects send 1 will send varying amounts of all of these channels out of this jack right here. And then what I've done is taken this cable, and the other end of it is right here. If we plug this into, I have an old MIDI verb here, we plug that into here, then when I play, you can see that we're starting to get level right here. So this is 1/2 of an effects loop. Basically, we've set this up as an effects send into this, but that's really of no use until we return the output of this back into the mixer. To complete that effects loop, I've brought in returns here, and that's what these cables are here, as long as I plug that into the outputs. So basically I have the send going in to the effect, and then the output of the effect going back and returning into here, and then if I press play, I should be able to you can see it coming up here. So you can see that's what an external effects looks like. There's a send from the console that goes into the effect, and then the output of the effect comes back in. Now, a lot of mixers will have specialized effect returns like this one. If you don't have effect return, you can actually bring it into any one of those inputs. But a word of warning is, if you bring it back into one of these inputs, don't then send that out here, because then you'll have feedback. Another method of patching in effects, particularly if they are dynamic effects like compressors and gates and things like that, is to use inserts. Now in this case we have an insert in all of these channels right here, and if we were to plug a tip ring sleeve, this is a special cable that is called an insert cable. It basically has a tip ring sleeve on one end and two tip sleeves on the other end. And here's what it does. As soon as I plug right in there, what it does is breaks into this channel, and then whatever we place in between these two cables will be inserted in line with that. So in this case we have a compressor, and I've labeled what this is all about. The red goes into the output and the grey goes into the input. And then so what that has actually done is just broken this and put it right in line. It'd be just like if we kind of put it right in line that way. So the insert cable, if you have nothing plugged into these other ends, it'll actually break. In fact, let me play that. Here's the kick and snare. Plug into the insert, the kick goes away, right? But then we plug that input into right here, the output right here, and now that kick drum is being compressed. If we pull it out, it's not connected. Put it back in, and it breaks into this channel and places this inserted within that channel. So let's have a quick look at subgroups, what they are and how we use them. If this was just a 12:2 mixer and we didn't have any subgroups, that would mean that all of these would simply go to the left and right bus, and then you would decide whether you pan them to the left and right with the pan pots right here. But because this does have subgroups, we can do some interesting things. So let's imagine we said before we have kick, snare, and hi-hat, and then bass guitar here. And imagine we had a whole bunch of other ones here, but at the moment we just have these four right here. How about we assign all of our three drum parts onto one of these subgroups? And here's how we do it. We'd set this up to sending out to 1 and 2. Now, when I hit play, they are being sent over here to 1 and 2. And if I bring up 1 and 2 over here and set this to go to the left and this one to go to the right, now this being set up as two different channels, and this going to the left and this one going to the right, then I could pan that hi-hat to the left or pan it to the right. So it's really kind of a two-step process. The individual channels are being sent over to subgroups, and then the subgroups are being sent over to the main mix over here. So let's imagine we want to take our bass guitar here, and instead of sending it over to 1 and 2, we want to send it over to 3 and 4. Now in this case we would bring this up and then set subgroup assigned to both left and right, and that would place it right down the middle. So what have we gained in this situation? What we've gained is that now we have subgroup of drums and a subgroup of bass. Well, bass is really not that important because we only have one channel over here. But let's imagine, let me just stop the playback right now. Let's imagine you had 1,000,000 input channels here, and you had kick, snare top, snare bottom, hi-hat, tom 1, tom 2, tom 3, tom 4, crash, ride, overheads. You had maybe a dozen different input channels here. And then when you wanted to blend your drums, let's imagine they were all set up this way. If you wanted to bring your overall drums down, you would have to grab all of these and move them down, and keeping their relative balances all equal. Or else, if you set them over to some subgroups, that way you could ride your entire drums just by a pair. Now, why using a pair? Well, using a pair if you want to keep your stereo assignments good. In other words, if your toms, maybe tom 1 was here, tom 2 was here, tom 3 was there, tom 4 was there. If you want to keep those assignments, you do need to set them to a pair of subgroups, and then you would set those subgroups, one to go all the way out to the left, the other one to go out to the right. On some mixes, you'll actually have pan pots up here, and then you will just pan them all the way out. So you can imagine what kind of inputs would be great candidates for using subgroups. Well, drums for sure, right? But what about things like, say, backing vocals? Imagine if you had a whole bunch of backing vocals, you could put them all to a subgroup over here, or maybe all your guitars together. But subgroups are just a way just to group a number of inputs together so you can have much easier control over a group of them rather than having to kind of finagle them all together. While we have our mixer here, let's look at the more standard inputs and outputs you'll typically see on an analog mixer. It will vary from mixer to mixer, but this will kind of give you an idea of what's going on. This area here is all about your effects. Your effects sends 1 and 2, and then goes back here to the returns. Again, that's an effects loop, so it goes out here and then returns back here. You remember that effects 2 was normally placed into your internal effects, but if you have nothing plugged in here, it will be routed to your internal effects. If you have anything plugged in here, that'll break that connection and allow you to use 2 effects. You then have a tape output and input. This is good for if you're recording. So you would take the tape output here. These are just RCA unbalanced plugs. Plug that into whatever is going to record, and then you can return that here. And that will come back into your mixer. Now, a main insert, just like we had inserts over here on our standard input channels, we also have inserts across the main left and right. And by the way, that's where the main left and right are coming out here. And why would you use inserts across your main left and right? Be great for maybe an external graphic EQ, or if you wanted to do some compression across your main left and right, that would be the place to do it there. Then we have the main left and rights in either balanced quarter inches, or we have XLRs over here. And there's a third output here, labeled S for sub out. So if you have some subs that are just handling all your frequencies from, say, 75 hertz and below, then plugging that into there will allow only the frequencies from 75 and below to come out there and feed your subs. And then when talking about subs, this is not sub as in subwoofers, things like that. These are your subgroup outs. So remember we had our subgroups before. If you want to send those out elsewhere, then you can do them right here. On older mixers, when you were doing recording, into 2-inch machines, things like that, that's where you'd be sending all of your record outs to. Then we have an auxiliary send, and then the auxiliary sends is our monitors over here. And that way, these can be great for, you could use them for a number of different things. Typically, you'd be using them for monitors. And then there's another one here just called utility out. If you need to just send your left and right bus to someplace else, you can use that right there. Here's where you set up your monitor sends. You can send varying amounts of each channel, and then there's a master here. So therefore, if you wanted to bring up your overall monitor levels on stage, then you can do that right here. If you want to send individual differences, say somebody said, I want more of the backing vocal too, then you could bring it up here. So this is the individual sends to a monitor. Here's the master of that monitor. In this particular mixer, you have a 9-band graphic EQ where you can kind of sculpt the sound of your main left and right bus. As we saw before, all of these are doubles. They're multiples. So 63 goes up to 125, 250, 500, 1K, 2, 4, 8, and 16K. And placed right in the middle is neither boosting or cutting that. If you bring it up, then you'll be boosting 16K or cutting 16K. So that's what a mixer does in a nutshell. Basically brings your inputs in, matches their levels, tweaks their EQ and dynamics, throws some effects on them, and then routes them out to the front of house, back on stage through the monitors, and elsewhere for things like recording, or maybe even other rooms like cry rooms in the church community, or foyers or entrances. Basically, bring the stuff in, massage it all, and send it on out. Now, if you're faced with being nervous about approaching a new mixer, remember, there's only really 5 things you need to know. First up, assigning inputs, setting levels, adding EQ, adding dynamics, and then routing your signal. I mean, now, there are more things like mute groups, or assigning a built-in graphic EQ to the monitor bus, and a bunch of other specific tasks, but you can get I tell you, you can get a whole lot done if you just know those five things I went through. Okay, so let's move on to troubleshooting.